Hello and welcome to TidyX episode 127. TidyX is a screencast where we go through and explain how our code works. My name's Ellis Hughes.
And my name's Patrick Ward. And as always, we have a YouTube channel. If you'd like to get in touch with us and ask questions similar to what we're going to answer today, you could drop a comment down below. If you feel like our work has impacted your work and you'd like to contribute to us, we do have a Patreon page as well. And we're thankful for anything that you can or would be interested in contributing. And today's question actually comes from one of our original patron
Yeah,
contributors.
so thank you to them for being with us for such a long time and being a patron
That's
of us.
awesome. Yeah, and so we're getting around to this one, and anybody who works with public data knows that name joining and name matching is the bane of your existence. Every website spells something different. So this individual had a question, and it's a question that I face every day, which is I'm trying to scrape a whole bunch of public websites, and I need to get them into my database and make sure that I can join them to the data that I have in my database, so that I can use the data from those public websites.
Mm-hmm.
So we're going to do this a couple different ways. The problem space here is under the assumption that we have a name bank. So let's say we work for, let's say, like a professional soccer team in the MLS, and we have some information from the MLS about soccer players around the world. And that information contains something like the player's name, the team that they're on. It probably has information like the league that they're in, some sort of MLS unique identifier, birth date, things
Whole
like
mess
that.
of information.
We'll call those the vitals. That's the name bank. And we're going to go out, we're going to scrape a bunch of data because we're looking at players in South America and Central America and Europe. We want to join that in. Whatever we scraped from their leagues, we want to join into our data set. So we have a complete data set of the world in terms of soccer. And even if you didn't have a name bank, if you were just at home scraping a bunch of websites, you're going to have to get to a point where you're keeping a list of names that it's like, you know what, I'm always going to call Bob Jones, and it's always spelled like this. And I'm trying to find all the other Bob Jones on all the other websites.
Yeah, Bob Jones on the Bulls.
So exactly. So here's our name bank. We've got Bob Jones, we've got Cam Hansen Jr. on the Bisons, we've got a BJ Franklin on the Bigfoots, and we've got a BJ Franklin also on the Bisons. So two BJ Franklins, and they play on different teams,
And they're spelled the same way.
and they're spelled the same way. So let's go ahead and set up our quick little name bank here.
Yep. Oh, quickly. Also, we are using library Tidyverse, and later on we'll use this cool library called Library Fuzzy Join.
Yeah.
So we'll load those in first. All right. So now we've got our name bank.
All right. So we go out, we scrape our first website, and this is what it looks like. It's got the name, the team, and some sort of measure of performance for the player in that game. I just made up arbitrary values. So you can see that when we run our new scraped website, we have a bunch of names, and they look somewhat similar to our name bank. Like Cam Hansen Jr. is a J with a lowercase r and a dot. There's a BJ Franklin on the Bigfoots that has a dot dot. There's a BJ Franklin on the Bisons that has a space. There's a Cam Hansen Jr. with a capital JR. And then it looks like in one of the leagues, some intern coded the name incorrectly and accidentally left out some letters. Not sure what happened there, but
they got distracted.
Yeah.
A senior leader came in and started distracting them and asking them some random
Correct.
questions about stuff. And they got really scared. They
Yeah.
tried to finish it real quick and go and help them. So
we've got something misspelled there. So let's see if we can get the names from our newly web scrape data with their performance measures into our data bank. So how can we get those joined to our data bank so that we're always looking at the same players? So I think we solved this in two different ways. Ellis did it in BaseR. I did it in Tidyverse with Wuzzy Joiny. Ellis is going to go first and walk through his solution.
Yep. Yeah. So we're going to use that. So the first time when I saw this problem, my first thought was, great, we're going to do fuzzy matching, right? That's the kind of the theme of today. How can I do it in a unique way that also is very approachable to people? And one tool that I've used in the past is agrep. So agrep is part of like the grepping regex family of functions that exist in BaseR. There's so many different sweet tools there. But the one that does fuzzy matching, so fuzzy matching is allowing you to match kind of similar words, is agrep. And so agrep and agrepl. So agrep returns indices or values, and agrepl returns a Boolean vector of true false. We can go through and start filling that out and kind of do a quick little test case here to see how it might work. So we're going to use Cam Hansen Jr. As is our kind of base vector that we want to be, or the base pattern that we want to be matching on. And so we're going to pass into agrep the pattern of Cam Hansen Jr. This is how we expect to spell it, right? With a capital J, lowercase r, and a dot. And Cam and Hansen spelled correctly, unlike that intern. So it takes that pattern of Cam Hansen. The next argument into agrep is x, which is the vector of strings that you're trying to match on. So this is very similar so far to like the grep function where we covered the earlier for regular expression string searching. X is now the what is the value that we enter into it. Agrep has some interesting values that you've got to add though, because the way agrep works, it has a cost, which is it tries to identify how different the string in X is from the pattern that you're passing to it. And so there's a number of different costs that you can see. So let's do $agrep to see the help page for agrep, and I'll move us over here while we're talking about this. So if you scroll down into max distance here, it talks about the various different costs that exist for the string matching. So there's this overall cost. There's the all, which is the total fraction of transformations, so insertions, deletions, and substitutions. So those are the three sorts of differences in a string that can occur that according to this function. Then there's insertions, which are the total number of inserted new values. There's the deletions, which is the total number of values deleted. And then substitutions, which are the incorrect values in your string. And so you can also then have costs, which is weighting some the insertions, deletions, and substitutions to have more of an impact in the distance calculation or not. But ultimately what it's going to be doing, it's going to be calculating the Levenstein distance between the string that you pass in, or the pattern that you match in, and the vectors of the strings that you pass here. And max distance is what's going to be a cutoff that it's going to say at this point we're going to consider this a match, after this point we're not. Next, there's a few more arguments, but the next one we're going to use, for example, you can use ignore case to say, hey, I don't actually care about capitalization, just match it on the actual string values. But the next thing we're going to use is fixed, because I actually want this to be seen as a string, not a regular expression. I want to exactly match this thing. Because, for example, this dot here can, in a regular expression, can mean any character. We want it to be seen as a dot. So we can pass this in, and we're going to run this on dfperf, and it returned 2, which is, if you look at dfperf name, the index of Cam Hansen Jr. So it was only able to match with this max distance of 0.01 to the exact same spelling. But if we loosen this up and increase the max distance to, say, 0.2, what it's going to do is now the cutoff is at 0.2. So it can match potentially more values. So now it's matched on the 2 values of Cam Hansen Jr., so 2 and 5. So Cam Hansen Jr. with a dot, and then Cam Hansen Jr. with a capital R. We can increase this even more to 0.5 to then match on that last horribly misspelled Cam Hansen Jr. right here. The downside of this is the more that you raise this max distance, the more likely it's going to have a false positive for matching with another string. And so there's going to be a max distance. This might have to be some iteration that you do to identify what is the maximum distance I'm going to be allowing, or how much false positives am I going to allow in my data set. So now that we know how agrep works, we're going to write a little function. Essentially what we're going to be doing is we're going to pass in db names, which is the names that I want to be matching on. So these are the potentially misspelled names. Preferred names, which is the spelling of the names I'd like to be using, and then max dist. That way we can kind of adjust it if we need to. I'm going to default to 0.2 because that seems like a pretty good starting point. I'm going to create an empty vector so that is the same length as DB names, because that's what I'm going to be wanting to be outputting, but it's only going to be filled with empty character strings. And I'm going to loop over every preferred name. It'll use a grapl, so this will return a Boolean vector. Same arguments that we had before into this preferred name location, and I'm going to drop in, if there's any matches, the location of the name that I'm trying into the location that I identified as similar with my preferred spelling of the name. And then I'm going to finally take that output, and then if there's any names that weren't actually matched, put an NA in there, because I actually do want to know that something was misspelled. So we can do that. Now we're going to take our df perf, which remember has our name, team, and performance, but this name here can be spelled a couple different ways. We can throw it into the mutate. We're going to use that get preferred name function that we just generated. And we can set this. Let me move us over there. I'm going to leave the max dist as 0.2. That's going to create this preferred names vector. I'm going to relocate it before .name, and I'm going to rename name to original name. That way I can see if there's any strange values here. And so now we can drop that in. We can see that Bob Jones matched, Cam Hansen is matched as I would expect it. BJ Franklin is now matched as I expect it. But because I had it at 0.2, the CMA Hansen didn't work. So I'm going to just increase that up to 0.5. And now I've matched on that. So this was like a simple way that you could do it. If there's within teams, you could do like a group by on teams and filter the unique preferred names based on team as well, and kind of increase the flexibility of this. But this is like the super basic way that I would approach this sort of problem. Patrick, how would you do this?
Yeah. So the way that I did this was I stuck with Tidyverse and I used the fuzzy join package. So the first thing I did in my head was, well, I've got to in some way find a way to match these on some sort of unique ID. So I said, what if I built my own unique ID? And the way that I did that was I took the data sets, the name bank and the newly scraped data, and I took all the names within those data sets and I put them to lowercase. So I basically said, hey, get rid of all the capital letters, just dump them to lowercase so that everything's on the same kind of plane. I removed any of the dots, so the B dot J, the JR dot. So to do that, I use G sub. The two little slashes are basically there to escape the dot. If I just put the dot there without the two slashes, I'm going to get nothing. I'm going to get a blank returned back. So I have to escape the period. So I escape the period and I say, anytime you see a period, remove it and substitute it with a blank space or a blank space. And then I go through that again. And this time I said, hey, if there's a blank space, get rid of that. Let's have nothing in there. So removing all white spaces.
Yeah, a white space character.
A white space character. Yeah.
Yeah.
Sorry. Yep. And then I create my ID by basically pasting their name together and then also appending the team to that, separating by an underscore. And that's the way I'm adding the team variable in here. You could also do a group by. If you had like thousands upon thousands of players around the world that are on similar that have similar names, similar maybe even names on teams, you could even underscore and put birth date or something like that. You could add other variables to make this as unique as you wanted it to be to the individual. So now that I have that ID variable for the scrape data, I'm going to do a fuzzy left join. So this is exactly like any of the joins that we've done in any of our episodes, and we've done a million of them by now. So the left join is basically I'm keeping the data in the left data frame, which is the scrape data, and I'm going to join it to our name bank. And I'm going to join it to the name bank by first, I'm going to go through all those steps to create that unique identifier in the name bank. There it is. I'm going to join on the ID. So this is important because if I don't specify that I want to join the ID between the two data frames, it's going to join on name, team, because those are shared. Those are shared names, and we don't want to do that. We just want to join on the ID. And then within fuzzy left join, I put in this argument that's called match function is string detect. So it's trying to detect the similarity between the columns that I'm IDing, the columns that I'm joining on, the ID columns. Okay, so if we were to run all of that through line 86, we're going to get a pretty long data frame, and you can see that it did its joining. It did the work for us. But now we have X and Y data sets. And so we need to do a little bit of cleaning to get this into a more palatable form so that it makes sense to us. And so that's what I do next. I basically go in and I say, hey, you know what, that name thing that I put to lower, let's just pop it back up to title case so that it looks like a proper name so we know what we're looking at. And then I'm going to select out the preferred name. So that's the data coming from our name bank, the original names, which is the data from whatever website we just scraped, the team, which is obviously the team. That's what we care about. I'm gonna keep that from the original data set or from the scrape data set, and then the performance, because that's what we're trying to get into our database. We're trying to join back to. So if we run all that, I should get a data frame that looks exactly like Ellis's, and it does. I miss on the original name, the CMA HNSNJ. And anybody who's done this stuff knows that there's always some manual elbow grease that goes into name joining and name matching. The idea with this stuff is, can I go from, let's say, trying to do manual matching of like 10,000 people to like 100 people or 20 people or 10 people?
Like,
Can I just find
can we reduce the problem space?
Exactly. So we could, if we were doing this over hundreds of websites, we might then filter down to the NAs and figure out, okay, what are the NAs and what does this look? And if there's something that starts to come up pretty frequently in terms of like a spelling, we can add that to our original name bank and pick it up later. And so then we don't have to do that manually later on. So yeah, that's a little bit of fuzzy name joining, solving the problem of fuzzy name joining at least.
Hey, yeah, and there you go. So those are two different approaches you can use. Both of them have their merits and their just understanding of the different functions that exist in the R space for solving this type of issue.
Yeah, cool.
Yeah. And with that, we're going to call it. Thank you all for joining us for episode 127. As always, my name is Ellis Hughes, and you can find me on Twitter at Ellis_Hughes.
Yeah, my name is Patrick Ward. You can find me on Twitter at OSPPatrick, at Tidy_explained is where we're both on Twitter. Tidy.explained@gmail.com is where you can hit us up on email. Of course, most people like and subscribe on the YouTube channel and drop their comments down below. We also have a Patreon page if you feel like the work that we're doing has impacted you positively. We're always grateful for anything you contribute, and super thankful for our Patreon subscribers, one of which who submitted this question a couple weeks ago, and we finally got to it, and we're very thankful for that. And so if you too would like to submit questions, that YouTube channel, like and subscribe, drop it down there, and we'll try and get back to you.
All right. Thank you all so much, and keep on exploring your world.